for our graphing guided practice. As you watch, please remember you have the ability to pause, go back and rewatch, and take notes as you go. Our learning target: I can make, use, and interpret different types of graphs. In our guided notes video, we learned how to graph with tails. So friendly reminder, T is for title, it describes our data set. A is for our X and Y axis. Intervals will be evenly counted or evenly spaced. Our labels are going to describe our X and Y axis intervals. And our scale is always going to be consistent. So the numbers will increase by the same amount, by the same value, whether that's 1s, 5s, or 10s on both our X and our Y axes. Our Y-axis always represents our responding or dependent variable. Our X-axis will always represent our independent or manipulated variable. First practice is going to use a pie chart. According to the pie chart, which species is the most abundant on Earth? Insects is the correct answer at 58%, biggest portion of our pie. What percentage of the graph includes human beings? Human beings will fall in this all other animals category, which is composed of 18%. How does the percentage of protists, which are simple, typically unicellular, so made up of one cell animals, compare to the percentage of plants with respect to diversity? Plants are 16%, protists are 4%, so protists are 1/4 or 25% of the number of plant species. Again, in this pie chart, notice how all of the data is represented in a percent of a whole. Our second practice, you are going to begin by making a graph using this data. Think about what type of graph you will make. Will you make a pie chart? Will you make a line graph or a bar graph? Hint, hint, look at your data. If you made a line graph, you would have been correct. We use a line graph because line graphs show changes over time. Minutes are a unit of time. We will always use a line graph when we have time, whether it's minutes, hours, seconds, years, centuries, in our data set. Question A, according to the graph, what is the approximate heart rate at 17 minutes? So at 17 minutes, on my x-axis down here, I have my time represented. Since time is an independent variable or manipulated variable in our experiment, it does not depend on anything else. It will just carry along by itself. So down here, I find 17 minutes, and I estimate where that is. I follow it up and across to find an answer of approximately 140 beats per minute. When is the heart rate at its peak? Peak meaning highest point. Again, I look at my data set here, my line graph, somewhere around 148 beats per minute. Using the results from the graph, describe what happens to heart rate before, during, and after exercise. Heart rate gradually increases as the body begins to exercise, peaks during intense exercise, and then gradually decreases as the exercise period ends. In your graph that you have made, please make sure you have all of tails with the title describing the data, our X and Y axis, label, a good scale and interval. You are going to make, for our third and final practice, a double line graph comparing the following. Again, we're going to be doing a line graph because we have time. Here it's represented in years. If you made a graph that looks like this, has a title, label, axis, scale, and intervals, well done. Question A, explain what happened to the chipmunk population from 2001 to 2011. The chipmunk population rapidly increased from 2001 to 2004. Then the population gradually decreased until it began to increase again from 2009 to 2011. B, explain what happened to the hawk population from 2001 to 2011. The hawk population gradually increased until 2006 when it peaked, and then gradually decreased until 2010 when it leveled out. Using the data from the graph to explain your answer, why do you think the populations changed as they did during the time period? As the chipmunk population increased, the hawk population had more food to eat, so their populations increased as well. Once the hawk populations increased, they preyed upon the abundance of chipmunks, causing the chipmunk population to gradually decline. As the chipmunk population declined, the hawks had less food to eat, which caused their population to decline as well. D, predict what this graph for the chipmunk and hawk populations will look like over the next 5 years. So if you were to expand this graph out, what do you think would happen? The chipmunk populations will continue to increase, providing more food for the hawks, which will in turn increase in population. As the hawk populations increases, they will prey upon more chipmunks, causing their populations to decline again. This is a typical example of a predator-prey graph, which are usually very cyclical, meaning they are a cycle, until they reach a point where they level off or reach carrying capacity. We will talk a lot about these type of graphs in our ecology unit.